Hey everyone and welcome back to PrepFusion. I'm Anish and today we'll start the second part of this basics of vector algebra and vector calculus lecture. Basically we are building the fundamental blocks till now. So I gave you as homework few questions, so those we will do, and few topics were also remaining, those we'll do. Then we'll start like with all the new topics that we learn in this lecture, right? So here we have to compute the following: length of ABCD. ABCD is this curved like shape, right? Then area of ABCD and ABO. O is this origin. Forgot to mark. O will be this origin. Okay, this is like a quarter circle. Then volume of ABCD. ABCD. FO. F will be this. Actually, F will be this. ABCD, F, and O. This whole closed surface, right? The volume of this. So first we'll go with this length of ABCD. How will we do this? So there are two ways to do about it. Go about it. One thing is your basic aptitude. What you know? This is straight line. This is straight line, right? Okay. This I haven't like marked the point is. Okay, that is bad of me. I should have actually marked the points over here. So actually this point, right? This is in the XY coordinate. So this point will be, this is Z. So here it is 5. In the X direction it is 5. In the Y direction it is actually 0. And this should be simplified. Okay. But can we write this in cylindrical coordinates? Actually we don't need to write this in okay, we will write this in normal this point like Cartesian format only. So this is actually this length, right, is bigger, so we'll assume this as 10. Okay, this is double, just almost double than this, so we'll assume this as 10. And what will be this actually? This will be x is 0, y is 5, because I'm moving here from 5 distance and moving at the top at 10 distance. Z is 10. Here everything will be same, just Z will be 0. This will be 0, 5, 0. This will be 5, 0, 0. Okay, this will be 5, 0, 0. So yeah, that's basically about the coordinates. And this point, right, this point is 0, 0, 10. Okay, totally lying on the Z axis. Now can you find the length? Now how do we find the length? Basically two ways to go about it. First is, this is straight line, so what is the length of this 10? What is the length of this 10? So total 20. Then I have to find the length of this what? Quarter circle, perimeter of the quarter circle. So this is like 1/4 of a circle, right? Like there will be another circle that will totally make it a semicircle. Then there will be another quarter circle, another quarter circle. So what will be the length of a quarter circle? Simply pi into r divided by 2, because the whole perimeter of a circle is 2 pi r. If I divide it by 4, I will get pi r divided by 4. 2 pi r divided by 4, that is pi r divided by 2. And there are 2 quarter circles, so I will get pi r. Simple pi times r. So it will be pi r, like method 1 is pi r plus 2 times L. Pi r plus 2 times L. So what is pi r? What is r? R is the radius, right? Radius is how much? Radius is basically 5. So this is 5 pi plus 2 times L. L is 10 basically, so this will be 20. So answer will be 5 pi plus 20. Now what if I want to do it in some other way? Okay, in the conventional method, okay, generalized method. So how do I solve it using generalized method? So if I want to solve it using generalized method, right, first of all I am observing that this is a shape like a cylinder. Okay, so I can solve this in the cylindrical coordinate system. So this will be 5 pi plus 20, whatever units this has, that will be this. Okay, now method 2, this was the part A actually. What is a incremental differential length in the cylindrical coordinate system? If you remember, this was d rho a rho cap plus rho d phi a phi cap plus z, not z, sorry, plus dz cap, dz az cap. So yeah, this we have to find out. So how do we find out? So if I just take a incremental length right here, if I just take an incremental length and I write the function, I'll be able to solve this. So what I'll do, I have to find the length of ABCD, right? AB and C, like ABCD, this whole thing, right? This whole thing I have to find out the length. So what I can do, first of all, I can go from A to B, then I can go from B to C the length, and then I can C to D, and then coming back to A again. Okay, so what does each point is, how does each point is defined in cylindrical coordinate system? So here x will change to what? Rho cos phi and rho sin phi, right? So what is rho cos phi? So what is phi? Basically phi, right, is the angle with respect to the positive x-axis, which is 0, because this doesn't have any angle with respect to the positive x-axis. This is exactly on the x-axis. So rho is 5 and cos phi is 0. So rho cos phi will be rho is 5 and phi is 0, right? Phi is 0 degree. And what is the z value? Z value will be same, z, which is 0 here itself. So it will be simply 0. What about the B point? B point, I'm observing that I have to rotate a whole 90 degrees to reach to this B point, right? But rho is still same, distance from the origin is still same, that is 5. Okay, 5, 90 degrees, and z will be still same, z is z, 0. What about C point? C point, right? C point is how much? C here, if you observe again, C point is, I have to rotate a whole 90 from the x-axis, but this time z is also 10, because I have to go above 10 units as well. So rho will be 5 again, this will be 90, this will be 10. And D point, similarly, it's just parallel to x-axis, so I don't have to rotate any angle from the x-axis, but the distance from the origin is is simply 5. So okay, this yeah, this is 5, right? 5. So it will be again 5, 0 degrees and 10. Okay, so we got this. Now we just need to find out the length. So how do I find out the length of ABCD? So what I have to do is, I have to integrate this dl vector, right, over the whole ABCDA to get back my length. Okay, length of ABCD. Okay, that is what I need to do. So how do I find out the length? So I just need to find out the magnitude, right? This, I will get a vector, I will just need to find out the magnitude. So what I can do is, I can break this down, I can break this line integration. So what I can do is, I can break this thing down. I'll copy this. This will be equals to, first I will move from A to B. Okay, do the same thing, then just copy and paste this. Okay, then I will move from B to C, then again I move from C to D, then again I move from D to A. I will overall complete a whole loop back, right? So what is A to B? So A to B means, simply I will just replace this. So here, what is changing from A to B? Yeah, sorry. So from A to B, what is changing? The rho is same, the phi is changing, and z is same. So basically I will just take the, like, so here what will happen? D rho will be 0, right? There is no change in rho, there is no change in z, so dz will be 0, just this component will remain. Okay, so here this will be rho d phi a phi. Okay, yeah, sorry for that. So, and how is my phi changing? Phi is going from 0 to 90 degrees, 0 to 90 degrees. Okay, or I can write this as pi by 2 as well. Okay, pi by 2 in radians. And what about BC? So in BC, change in rho is 0, change in phi is 0, but change in z is there. So I will just take this component, all this component will be 0, because d phi is 0, d rho is 0. So this will go from 0 to 10, z is changing from 0 to 10, simply dz az cap. Okay, plus I actually what I want, I simply want the length of this particular things, right? I just simply want the length. So I'm interested in the length, so I will ignore the vector for now. Okay, I will ignore the vector for now because I'm not interested in the direction. I'm just interested in the length, so I will not write this in direction vector format. Okay, next is CD. Actually CD is almost same as AV. Rho is not changing, Z is not changing, just phi is changing, right? Okay, vector format, actually we have to do this because I'm just interested in the length, so I need to use the magnitude of this, right? I will just take the magnitude of this. So yeah, this portion, right? What I am mostly interested in is the magnitude. So if I want to, if I am interested in the magnitude, right, I will just take the magnitude of all of this. Even if this is computed in vector format, I'll just take the magnitude of all of this. Just hold on. Okay, so even though there is a like arrow cap here, but I will just take the magnitude. Okay, just to maintain the consistency. This is Z cap plus this is going from pi by 2 to 0 degrees in the magnitude. This will be rho d phi a phi plus again the same thing, only here I am going from 10 to 0 again, right? But I don't care about the direction, I just care about the length. Actually I just care about the length. Okay, so yeah, that is what I will do. So this is the length. Ten to 0. Okay, dz z cap. So what will this come out to be? Rho is what? 5 into pi by 2, so 5 pi by 2, 5 pi by 2 times 2 plus, because this is repeated, because I will not take care of the magnetic negative sign, just I will make it positive because I'm just taking the magnitude, I'm just interested in the length. Okay, plus this, right, 10 times 2, so we get 5 pi plus 20 units. So exactly what we got here. Sometimes common sense actually gives you answer quickly, but this also is a good method to have if the shape is unknown to you. Okay, if the shape is unknown, in this way you will be able to find out the answer. Now we have to find out the area of ABCD. How do we find out the area of ABCD? So again, what do we know? How do we compute the area of this particular surface, right? So in which direction is the surface is? So if I observe the direction, right, is actually pointing out, like if I just observe the surface, direction is in this direction. What is this direction actually? This direction, if you observe, this is in the arrow cap direction, because arrow cap is something like this. Arrow cap is pointing outwards from the origin, right, pointing outwards, and the direction of the surface is also same, pointing outwards. Just the phi is changing. Here what is changing? From here to here what is changing? Phi is changing. Rho is constant, right, because rho is constant. If you observe, this rho is always constant. Rho is always constant. Rho is always 5. Rho is 5. So d rho, like basically d rho is 0. I have to take the other two components. D rho is constant. Rho is constant. Remember, rho is constant. So I have to take the other two components. Phi is changing. Phi is changing from 0 to 90, and z is changing from 0 to 10. Okay. So what will be the direction of my surface vector? So I am solving the second part here. The direction of my surface vector, right, will be simply arrow cap, and it will be plus arrow cap because I am pointing outwards here, not this direction, right, not this direction, I'm pointing this direction. Okay, so it will be plus arrow cap. That is established. And what are the other components? If you remember, I have to take only this, like d rho is, I don't have to take this component, just take this component and take this component, rho d phi and dz. So basically I will take rho d phi and dz. Okay, so this component, these two components I will take for the surface vector. So basically what will be the integral? The surface integral will be something like this. I will integrate, this is a open surface, and it will be rho d phi dz e rho. And what are the limits actually? If you remember, like I can put the limits anyhow. Okay, I can put phi first, z first, because rho is constant. So phi is going from 0 to 90, right? Phi is going from 0 to 90. So phi is from 0 to pi by 2, and z is going from 0 to 10. Simple z is going from 0 to 10. So now we can simply solve it. This rho is constant, that is equals to 5, and dz integrating this, all these are constant, right? Simple constant. So this will be into pi by 2 into 10. Okay, so this will be 25 pi unit square. Okay. So this will be the answer for this particular question. So like how you would have solved this simple, if this surface, right, the equation of the surface would have been given, then things would have been difficult here. This we have solved previously as well. If you remember, in our integration chapters, we have solved multiple of these types of questions where some function was given and we were integrating, we are doing the double integration. So I think you can do this. Is the more simpler portion. Okay, so what about the surface area of OAB? What about the surface area of OAB? Now this one, right, also you could have done in using simple logic also. Okay, that is homework to you. Now let's do the surface area of this OAB. Or ABO? How do you do this? First of all, simple logic is, this is a quarter circle. So surface area of quarter circle, right? Surface area of quarter circle, that one. Surface area of quarter circle, right, will be simply, first of all I need to write the magnitude. Quarter circle will be simply pi r square divided by 2. No, not 2, sorry, pi r square divided by 4. Right, so it will be 25 pi divided by 4. This is the method 1. Okay, what about the method 2? What about the method 2? So method 2 basically is the simple logic again. Now what is the direction this time of the surface? Direction will be outward. It is plus az cap, right? Plus az cap is the direction. Not plus, minus az cap is the direction. And if az cap is the direction, what is constant? Z is constant. This is lying in the xy plane, so z is constant. Z is not varying. What is varying? Phi is varying, and rho is also constant. Is rho constant? Yeah, actually rho is also constant here. But I have to compute this surface. Rho is actually not constant. I have to take care of this whole surface. So what I am talking about is this whole surface, right? Because so in this surface, what points are lying? This point is lying, this point is lying, this point is lying, this point, this point, this point. So here rho is something different, here rho is something different, here rho is something different, here rho is something different. So rho is varying, and my phi is also varying from 0 to 90. But my z is constant, right? Z is constant. So what will I choose? Again, this time my surface vector will be ds vector will be d rho and rho d phi. So rho I will write here first, d phi I will write here. Then what is the direction is minus az cap. Direction will be in the negative direction of az. Okay, that you have to take care of. Now I will simply solve this, right? What will the surface vector integration? It will be double integration of simple ds or double integration. How is my rho is varying? Rho is varying from 0 to 5. How is my phi varying? Phi is varying from 0 to pi by 2. This is rho, d rho and d phi. So now it's a function of rho, so I cannot simply use the constant formula here. So this will still be remaining pi by 2, and this will be rho square by 2, 0 to 5 d phi. So 25 by 2, and this will become 25 pi by 4 again. So this is the generalized method, and using basic also you can solve. Okay, so I'm just teaching you the basic things. This will be helpful in electrostatics. Given 2 points, this m and n. Okay, determine the distance from the point m to the origin and the distance from n to the origin and the distance between points m and n. So what is the distance from the origin? Distance from the origin will be simply like this, right? It will be the magnitude of OM, right? That is the distance from the origin. So for a Cartesian, it's cakewalk. Simply, it will be the under root of 2 square plus 3 square plus minus 1 whole square. This one we already know. So what is this? This is simply under root 9 plus 1, 10, 14. Under root 14. Okay. Now, the distance from point N to the origin. The distance from point N to the origin. So what is the distance of point N? So it is simply not 4 actually, simply not 4 because I have Z as well. So where does point N lies? So point N will lie somewhere from here, right? If you remember. So my radius is 4, okay. I have to move around the angle of 50 degrees, then move top by 2. So I will be lying around here, right? So even though this distance, right, is 4, but this is also 2 distance. This height is 2, right? This base is 4. So what will be this distance? This will be simply like the Pythagoras theorem, right? 4 square plus 2 square. So did I need any value of phi? No, right? I didn't need any value of phi, any information of phi. Without phi as well, I could have computed this distance, right? Okay. Without that, I would have computed that simply. Okay. I would have computed the distance of the point N from origin. So this will be simply so this, right, will be simply 4 square plus 2 square whole under root. Okay. So can you tell me one thing? What is this is the distance? Okay, whatever this is like 4 square 16 and 20. So under root 20, right? Under 20. Now the important portion is, can you tell me the direction of this OP vector? Can you tell me the direction? So what is the direction of this arrow, right? The direction of this is arrow. Arrow. What is the direction of this? The direction of this is AZ, right? AZ, correct? Now, what will be the direction of this? So how much arrow is this? 4 arrow, right? 4 arrow. So ON vector, how can I write ON vector? 4 arrow plus what? Plus 2 AZ. Like 4 of this and 2 of this. So did I need any A5 information here? No. So I proved to you that the position vector doesn't have any A5. Okay. The arrow, like inside arrow, this information about phi is already hidden because arrow takes care of that. Okay. I hope you got the point. Now let's solve this third portion, the distance between the points M and N. Okay. So you can solve this two ways. Either you convert everything into Cartesian or you convert everything into polar. Okay. Two ways. So I will do this using two ways only. I will convert everything into Cartesian first. So if I convert everything into Cartesian, what will be like x1 m is this, m is easy, right? x1 equals to 2, y1 equals to 3, z1 equals to minus 1. What about x2? x2 is rho cos phi, right? So you are observing that inside x already this information is hidden. Rho, what is rho? Rho is basically simply 4 and phi is 60. So this will not 60, 4 cos 50 . y2 is rho sine phi, that is 4 sine 60. So I haven't yet taught you this point conversion, but this is simple, right? This we have learned previously as well. And z2 is simply z2 only, that is simply 2. Okay, so simple mn, what will be mn vector? x2 minus x1, right? So this will be 2 minus this. So what is this value? I will just quickly compute this value. Okay, so 2.57. okay, so this is 2.57. this is simply 3.06. okay, so plus 2, so 7a x cap plus 3 minus this will be almost 0, ay cap plus minus, not minus 1, sorry. Okay, I have done a bit of wrong. This should be right. This should be like this. 2 minus 1 az cap. This should come here. Okay, so this is the case. Now if I find the length of this, 0.6 whole square plus 0.57 whole square plus 3 whole square under root, this will be almost 3.05, something like that. So length of mn, right? Now can you do it the other way around? Can you, method 1 is this, converting everything in the Cartesian. Now homework for you is method 2, that is converting everything in cylindrical. Okay, I will just write the homework, everything in cylindrical. Okay, that is the homework for you, and then compute, you will get the same value. Now we will do bit of point conversion, right? So if I have been given x, y and z, right, then how can I write this? Like or if I have to find out x, y and z, how can I find it out? With the help of cylindrical or spherical. Okay, if I want to go from spherical, cylindrical to Cartesian, so I have been given phi, I have been given rho, so it will be simply rho cos phi. How is it rho cos phi? How is x equals to rho cos phi? You divide this into a triangle, this and this, right? So the hypotenuse is rho, the angle is phi. Okay, now if I do rho cos phi, hypotenuse times the cos of the triangle, I will get the base. And if I do rho sin phi, I will get the height. Okay, height is basically parallel to the y axis, so it is simply the y axis component, and this is simply the x axis component. This doesn't have any information regarding z axis. Z is simply z for the cylindrical coordinate system. For the spherical, what is happening? This is again wrong. This should be actually here theta, this should be here phi. Okay, so here observe, I have two triangles. This is one triangle and this is other triangle. Okay, so I will just draw these two triangles. This, even though already have been taught to you, still just giving you a quick refresher. Okay, quick refresher. This is one triangle and this is the other triangle, right? So the interesting fact over is this other triangle, right? Theta is there. So again, this is the hypotenuse, this is the base, this is the sorry, this is not the base, this is the base and this is the altitude, right? This is the opposite of hypotenuse, opposite of the angle. So if I do r cos theta, what will I get? If I do r cos theta, I will get the z component, right? I will get the z component, and exactly that is what is written over here. The z component is done for the spherical coordinate system. What about the xy component? If I do r sin theta, I will get what? I will get rho. This is actually rho. Okay, this is another triangle. If you observe, this is another triangle. Okay, and this component, right, or this component is parallel to the rho. Okay, so rho I will get by doing r sine theta. So rho is r sine theta, and I know how to convert rho into x and y, okay, with the help of phi. So here that's why instead of rho I have just replaced with r sine theta. So rho, sorry for the noise outside, it's raining outside. Rho is basically r sine theta, okay. Rho is basically r sine theta, that's it, right? And z is simply r cos theta. We have changed z. Okay, this is simple point conversion. Now if I want to come back to Cartesian slash spherical, from Cartesian spherical to cylindrical, if I want to convert Cartesian to cylindrical, right? So how do I convert Cartesian to cylindrical? Again I will follow the same rule. I will just delete, actually I'll delete this because this, right, this doesn't have any, this is a bit wrong. So what is this? This is simply a triangle, right angle triangle. So x square plus y square will give me the hypotenuse, that is the rho. So exactly that is what I am doing, and taking the under root obviously to get the particular length. And phi will be what? Phi is this angle, right? Simple. What I know, tan phi is height upon base. That is exactly what I have done. I have taken the tan inverse to get the exact value of phi, okay, in radius. And z in case of cylindrical is simply z itself. There is no conversion, but in spherical this will change. Okay, that we have just established previously as well. Okay, this is actually, okay, this is cylindrical. For Cartesian there is no conversion, simply z only. For cylindrical, for spherical, what is the thing? Z simply becomes r cos theta, as mentioned previously as well. What about this? So here actually one interesting thing we have is what is rho in the spherical coordinate system, right? So I told you, right, if I just take the r sine theta, this component, this is the parallel of this component, this will actually be the rho component, right? Rho component that I have explained in the previous slide. So rho will be equals to r sine theta, and that's it, right? Phi is directly related with this. For spherical there is phi itself, so phi equals to phi for spherical to cylindrical, they are same only, and z changes to r cos theta, okay. So and for Cartesian z is z, okay, there is no conversion, okay. Now let's come to the spherical conversion, okay. Let's come to the spherical conversion. So for spherical conversion things are simple. Simply r will be equals to what? Here, right, if you observe, this is a triangle, this is a right angle triangle. So rho square plus this y component will give me the r, right? What is this y component? This is simply z, right? In cylindrical this is simply z. So rho square plus z square gives me r, and obviously I have to take the under root to satisfy the Pythagoras theorem. What about the Cartesian? This length is given to me by x square plus y square. If you observe, this length is given to me by x square plus y square. I got this length, okay, and if I again square this, then add with z square, I will get my r, right? And exactly that is what I am doing. So this rho square is basically hidden in here, okay. Then what about the theta? Now theta, right, again this is a triangle, this is rho, this is r, and this is theta. Again, what is height upon base? So height is rho, base is z, so that is why height upon base, and tan inverse of that will give me simply the angle theta, okay. And rho is again x square plus y square under root, that I replace, and z is simply z, right, from Cartesian to cylindrical. Once you get the hang of it, right, that's it. You don't have to remember all this. This should be inbuilt in your memory. This should be in the ROM portion of your memory. This is inbuilt, right? You don't have to memorize all this. And phi is simply tan inverse y by x if you want to convert from Cartesian to spherical. Okay, this phi thing is simply like, this is the x component, this is the y component. So not this is the y component, this is the x component. So tan inverse y by x. Okay, so that's how we get the answer. Now can you do this? Convert a point p equals to minus 1, 1 defined in Cartesian coordinate system to cylindrical and spherical coordinate system. Okay, so here there is a trick that I will show to you. So simply what you can do is you can use simple brains, right? Where is the point located? Point is in Cartesian coordinate system. So if the point is in Cartesian coordinate system, how will you do in cylindrical? So cylindrical, I know what will be the rho will be basically the triangle in the xy plane. So it is the square of the length, under root of the square of the length of these two. So rho will be minus 1 whole square plus 1 whole square. So it will be under root 2. Okay. What about phi? So phi, you will do simple this, right? You will do tan inverse y upon x, right? That gives us the angle. So it will be 1 by minus 1. So we will get as minus pi by 4, and z is simply z. There is no conversion, that is 1. Okay, and unfortunately this will be wrong. Okay, why this will be wrong? Because you didn't pay attention. So if you know one thing, you have to really master how to understand angles. So if you observe the point, right, what is the point actually? So if I just draw the xy for now, the point, if I just take in notice of the xy, right, it is in minus 1, this is, let's say this is x, this is y, it is in minus 1 and 1, okay, here, somewhere here. And what was phi supposed to be? Phi was supposed to be the angle with respect to the positive x-axis, okay, angle with respect to the positive x-axis. So here I observe, obviously this is wrong. Okay, obviously this is wrong. If you remember one thing, if you have learned basics from me, I have taught you how to calculate angles multiple times, thousands of times. If I am lying in this quadrant, this is the second quadrant, then the angle will be simply, angle formula will be simply pi minus tan inverse magnitude of y by magnitude of x. Now you don't tell me how did this formula came, because I have explained this multiple times in my previous lecture, so I will not explain it here. Okay, I will not explain it here. Pi minus tan inverse of, I will take the magnitude, I will not take care of the sign, because I already have taken the effect of second quadrant. So this will be 1 by 1 pi minus pi by 4, this will be 3 pi by 4. Okay, so this will be the actual angle, not the minus pi by 4. That is wrong. Okay, so that's how you do this. And about the spherical coordinate system, also you can do this simply. Okay, so how do you do spherical? If you know, remember, the spherical range for theta of spherical coordinate system is from 0 to pi only. Okay, it's from 0 to pi. So this was about the first part. Let's solve for the second part. Second part is spherical coordinate system. Spherical coordinate system, I have to find r. R is what? R is simply x square plus y square plus z square whole under root. So x square is minus 1 whole square, y square is 1 square whole square, and z square is 1 square whole square. So this will be 3 whole under root. Okay, 3 whole under root. Now what about the theta? The theta will be simply rho upon z. So what is this? Is tan inverse. Rho will always be positive, so one thing I am relieved. And z, if it is positive, it will be from 0 to pi, and if it is negative, it will be more than, so not pi, 0 to pi by 2 if z is positive, right? Let's draw the coordinate systems. So if z is positive, I am lying somewhere around here. So here the angle with respect to the positive z axis will be between 0 to pi by 2. If z is negative, I am lying somewhere around here. So angle will increase. So angle will be from pi by 2 to pi. Okay, I hope you get the point. So all of it depends on the value of z. So rho is how much? Rho is under root 2. And z is 1. Z is 1, rho is under root 2. Okay, so theta will be equals to what? This will be under root 2 divided by 1 tan inverse 54. So this will be 54.735 degrees. So yeah, this will be the answer basically for the particular question. And what is phi? Phi will be same, right? Phi will be same as the previous cylindrical thing. This will be simply 3 pi by 4. Okay, So this is how basically you solve this question. So I hope you got it. If you couldn't, just rewind and repeat it again. Now we'll study the vector form conversion. So let's do the vector conversion. We have done the simple point conversion, which is simple scalar conversion. Now if we do the vector conversion, how do we convert it in vector? How do we convert it in vector? So just keep a note and focus fully on the lecture right now. So this time, right, this is a bit difficult. This is a bit difficult because you have to memorize few things. You have to memorize. There is no other way. But I will make it easier for you to memorize. Although I think vector conversion has already been taught, I will just tell you some other way. If it is good for you, you can remember this, or you can remember the other way that Himanshu has already taught. Okay. So if I have a vector in in cylindrical coordinate system, and I want to convert it into basically Cartesian coordinate system, how do I go about it? So how do I remember? There will be matrix. Okay, there will be matrix. You have to understand the form. First form will be there will be three components in the X, three components in the not X, three components of the Cartesian, three components of the cylindrical, and in between there will be a 3x3 matrix. Okay, all of these are column matrices. Okay, now if I want to go from this cylindrical to Cartesian, how do I do? How do I convert? First thing, right? First thing you have to identify. These are the components of X, Y, and Z, and these are the components of rho, phi, and Z. Point 1. Next point is your X can be written how? X is equals to rho cos phi. X equals to rho cos phi. So this is the technique that I am teaching you. How do you write this? How do you write this? So as X is equals to rho cos phi, so you just in this first element, right? You just hide this row. You just hide this row and just write cos phi and then sin phi. Cos phi and sin phi. Now as Z is itself equals to Z only, so I will not do anything. I will just write 0 over here. Okay. So what you do when you are converting from cylindrical to Cartesian, you write X equals to rho cos phi. This we already know. This is simple thing that is inbuilt in our brains. Y equals to rho sin phi and Z is simply Z. Okay. So there is no phi component here. Okay. Z is not a function of phi. Z is not a function of phi. So as Z is not function of phi, so I will write 0 over here. And as X is function of phi, what is it? It is cos phi. It is sin phi. So I simply write this. Okay. In the first column. In the next column, what I'll do? I'll simply differentiate this. This, right? I have simply differentiated this. Okay, with respect to phi. And in the next column, I simply differentiate with respect to Z. Okay, with respect to Z, I simply differentiate with this simply 0, right? Z doesn't have any function here, but here as Z is equals to Z, I will simply write here Z itself. Okay, so actually what I am doing here is simply, right, in this first thing, in this first column, actually the main thing is I am differentiating with respect to rho. If you observe carefully, if I partially differentiate with respect to rho, I will get cos phi. If I partially differentiate with respect to rho, I will get sin phi. And if I partially differentiate Z with respect to phi, with respect to rho, I will get 0. Okay. And in this, right, I am simply partially differentiating with respect to phi. Particularly this thing, right, this thing. And here, actually, I am partially differentiating with respect to Z. Okay. Partially differentiating with respect to Z. If I partially differentiate with respect to Z, what do I get? This will be simply 0, 0, and this will be simply 1. And exactly that is what is happening over here, right? So yeah, this is how you solve. So you have to remember this, that this first row will come partially differentiating with respect to D row, and this second column will come simply partially differentiate this with respect to D phi, and this third column is pretty simple, right? Z will be equal to Z, so only 1 will be present and all the other elements will be 0. Now, if I want to go the other way around, so this is the conversion for cylindrical to Cartesian. So you might say, sir, what is the conversion for Cartesian to cylinder? So if I have Cartesian and I want to convert to cylinder, how will you go about it? What you will do is, like you remember this. I will write this, remember this. Only you have to remember this portion. Okay. Remember this. And how to remember that also I have told. Now this, let's say, is some matrix M. Okay. This is some matrix M. Now I have to multiply by M inverse on both sides. Then I will get the M rho, M phi, Mx in terms of Mx, My, Mz. Okay. So this is my M inverse, right? This is my M inverse basically. And one basic property of this type of vector conversions is that M matrix will be orthogonal. Okay, M matrix will be orthogonal, so hence M inverse will be M transpose. That is property of orthogonal. So this I already know, orthogonal. Okay, so this is a property. So if I want to find the inverse, right, I just take the transpose. So this thing, right, is just M transpose, nothing else. This is just simply M transpose. You just converted all the rows, all the columns into rows. Okay, written all the columns into rows. That's it. So remember this, and from this you come to this. Just take the transpose of the matrix. That's it. That's it, right? Simple. Now same format I will do for spherical as well. Same format I will do for spherical as well. Now for spherical, okay, this is for what is it? Okay, this is a unit vector conversion. Simply like this was for the components conversion. If I want to write the components, now unit vector conversion is same. Okay, if I want to convert the unit vectors, like how can I write Ax in terms of A rho and Fi? Okay, how can I write it? I can write it like this, right? It will be Ax cap will be simply everything is same, just here I have changed the components, right? A rho, Fi, that's it. So my Ax cap will be simply cos phi A rho cap minus sin phi A phi cap. Now what is my A rho cap actually? What is my A rho cap? So my A rho cap actually, if I observe here, my A rho cap equals to cos phi Ax cap plus sin phi A y cap. Now why am I giving this emphasis? If you observe, I told you previously, right? I told you that A rho cap is actually already the information about phi is hidden. You can observe here. You can straightforward observe here that the information about phi is already hidden in this unit vector A rho cap. Okay, so that's why I mentioned that while writing the position vector, I don't need this. I don't need the A phi cap. I have already the information of phi. Okay, so that's why. So for unit vector conversion is nothing, just simple, just change these components to vector format and that's it. That's it. Nothing else you need to do. This matrix will remain same. What you need to remember? This matrix. How to remember? I have told. Just rewind. Go back and rewind. How to remember? I have explained. Okay. Now let's come to the spherical coordinate system. So again for spherical, what I will do is, again I will differentiate this first column with respect to phi. So everything is same here. This is M. This is not rho. This should be R. Sorry. Should be R. Okay, sorry. Okay, we are converting in cylinder. Okay, we are converting in cylinder. Sorry, this right. Actually, this is. I will write this actually. Like this is from cylindrical to Cartesian. Okay, but vice versa, right? Vice versa. Same thing is for unit vector conversion as well. Just let me check if everything is recording or not. Yeah, everything is recording. Fine. Yeah. Here, this conversion is from cylindrical to spherical. Cylindrical to spherical. Okay, so same procedure. I want to write this first column. How do I do? So I like this. You have to remember. This you have to remember. Actually, I will convert. Like, how do I write this? Actually, like, why am I writing rho equals to r sin theta and not writing r equals to rho by sin theta? Not writing that. Why? Because this is a simpler format. Okay, I can break down the components of r in terms of rho and z. So you have to write it like this. Okay. You have to write this format, not r equals to rho by sin theta. No, not that. Okay, here as well, I could have written rho equals to x by cos phi. I'm not writing it. I can break down x and y in terms of rho and cos phi in components. That's why I'm writing. So this much you have to remember what to write. You have to write this only, not the other relation. You have to write this only, not the other relation. Okay. So here I have rho, phi and z. So I have written this. Now what I do? I simply differentiate this with respect to r, partially differentiate this with respect to r for the first column. So this first column is simply again d dr. Okay, I differentiate this with respect to r, and I get sine theta, I get cos theta. Okay, next again I will differentiate the next column with respect to partial differentiate it next column with respect to theta. Okay, so if I differentiate with respect to theta, sine theta differentiation will be sine theta, cos theta, and cos theta differentiation will be minus sine theta. Then in the last row, I will actually differentiate this whole thing with respect to phi again. Okay, partially differentiate with respect to phi. So if I partially differentiate with respect to phi, this will be 0, this will be 0, and this will be 1. Same procedure I followed in the previous like conversion as well. Okay, same thing I'm doing again. This will be just this, if this is m, if this is m, right, this is m, so this will be m transpose. As I know by property they are orthogonal. I know by property they are orthogonal. Okay, so you have to remember this and you will get back to this. Okay, just take the transpose. That's it basically. Now let's do this. Let's do this vector conversion. Unit vector conversion, you already know. I've explained this in the that just change these two unit vectors and you will get back the same results. Matrix will remain same. Now this conversion is for the spherical to Cartesian. Spherical to Cartesian. Okay, so x equals to rho cos phi, and how can I break this down further? Is equals to r sin theta cos phi, right? So again I'm breaking down in terms of components. I will always break down in terms of components. Okay, so this you have to remember what to write. Remember what to write. Then again you write here, I want to get x, y and z, right? I want to get x, y and z, and here r theta and phi is there. So the first thing that I will write will be a differentiation with respect to r. Okay, so if I differentiate this first row with respect to r, what I get del r. Okay, so if I differentiate this, so this will go away. Only sin theta cos phi will be there. Only sin theta sin phi will be there, and here cos theta will be there. If I differentiate this with simply with respect to r, then here I will just differentiate this with respect to theta. I will differentiate this from the first column. Partially differentiate with respect to theta. So this will be this will become cos theta, and this will change to minus sin theta. That's it. Now this row I will differentiate this with respect to phi for this particular thing, right? Okay, I will again come back from here. With respect to phi I will differentiate. Okay, here I will differentiate with respect to phi. So this one comes sin phi, this one comes cos phi, but actually I have to remove this cos theta as well. I cannot write this cos theta, so I will actually differentiate this with respect to phi. Okay, but I should not take the previous components because those have already been taken care of previously. Okay, so I cannot, this much you have to remember, that I cannot take the previous theta and phi here, right? Only phi will be present. Okay, only phi will be present, so differentiation of this is 0 only with respect to phi. Differentiation of this with respect to phi is simply cos phi. So cos phi is there, but r sin theta should not be present, and here as well r sin theta should not be present, it should be gone. Okay, so this thing you have to remember. Sadly, this thing you have to remember. Okay, so yeah, that's how you write this matrix. And next is pretty simple. Next is just the transpose of this. If I do the opposite conversion, you will just take the transpose. Simple unit vector conversion you will be able to do, right? Simple unit vector conversion you will be able to do. Just simply replace the vectors. Okay, replace these components in unit vector. So actually I have to do this as well. I will do this here as well. This thing also I have to do, right? Unit vector conversion. Actually this whole thing I will copy. No. Yeah. Where did you go? A row okay. So this will be again air cap A theta A phi. Is it okay? So this will be the case here. So yeah, this is simple unit vector conversion, and this is also same unit vector conversion. Okay. So all this is done. Now let's do few questions. So can you convert this m vector into cylindrical coordinate system using the conversion that I told you? Okay. So how do I will do this first question. So I have to convert from cylindrical to from spherical to cylindrical, from spherical to cylindrical. So if I remember in my mind, spherical is the simplest format, cylindrical is a bit complex. Okay, I write it like this. If you remember, just think cylindrical spherical, cylindrical spherical. So if cylindrical spherical is there anywhere, so you will write first rho will be what? R cos theta, not cos theta, sorry, R sin theta, and your phi is simply phi only. Okay, phi is simply phi only, and your z is simply R cos theta. So this thing you have to do. Okay, it doesn't matter from in which direction you are going, whether from cylindrical to spherical or spherical to cylindrical. Whenever there is conversion between cylindrical and spherical, you will write this relationship. Then what you do? You will do this, right? Simply there is m vector. Okay, m vector is R AR cap. So I have to get back to, like, first I will write this, that I need m rho, m phi, mz. This equals to the vector. What is the vector? I will partially differentiate with respect to r first of all. So this will be sin theta, this will be 0, this will be cos theta. Then I will partially differentiate with respect to theta, okay, of this first column. So this will give me cos theta, this will be 0, this will be minus sin theta. Then again I will partially differentiate this whole thing with respect to phi. So this will be simply 0 1 0. Okay, and all these are components. All these are components of what? M vector. So m vector, first one should be mr. So this is r itself, and this is 0, and this is 0. All other components are 0. So simply my m rho will be, now if it was other way around, if let's say m rho, m phi, mz was given, then you would have written the other, like you would have first written this, then you would have taken the transpose of this, then again written the relationship, correct relationship, right? So that's how you go, that's how you follow. Just remember this one thing, and from this base you derive all the other things. Okay, so this m phi will be simply r sin theta, and m rho is r sin theta, m phi is simply 0. Okay, m z is r cos theta. Now this we already knew actually, but that's fine. So your unit vector will be simply this, right? Unit vector will be basically your m vector will be r sin theta arrow cap plus r cos theta a z cap. Now one thing you should know is they have asked me to convert everything from spherical to cylindrical. So this should not be in spherical function, this should be in cylindrical. So what is r sin theta? I know this relationship, r sin theta is rho. So I will convert this into rho. So this will be a rho. What is r cos theta? R cos theta is simply z. Okay, so this will be z as it. Okay, this will be my m vector. So I hope you got to know how do we convert this, right? How do we convert this step by step? Okay, because just remembering everything will be very difficult. Just remembering one thing and deriving the others is the easier way out. Okay, so can you solve this question? So this question is pretty simple. You have to integrate a rho az with respect to d phi. Now I know that a rho cap like it's just in the rho direction, right? It doesn't depend on d phi, so I can simply directly integrate this. And z also doesn't depend on d phi, so I can directly write that all these are constant, so this will be from 0 to 2 pi, so 2 pi into e rho plus az will be my answer. Okay, but unfortunately this will not be my answer. Why this will not be my answer? Because I have just derived in the unit vector conversion itself that my rho and phi actually my rho and z actually depend on the angles, okay, in the xyz. So here if you observe correctly, where did it go? Here my e rho actually is a function of phi. My e rho is actually a function of phi, so you have to take care of that. You have to take care of that, right? So e rho, I will just copy and paste. I will not do the unit conversion because I have just taught you just in this lecture itself. So e rho is actually a function of phi, so I cannot simply integrate this as simple constant. This is here phi is actually varying, phi is changing, so here phi is also changing, so I cannot simply take it out of the integration and just simply multiply 2 pi. I cannot do that. Okay, a rho is this. What is az? Az is simply az only. Okay, az is simply az only, so az is not a function of phi. Az is simply az only. It is not a function of phi because this is in the cylindrical coordinate system, right? So what I can write over here, I can break this integration down. I can break this integration down. This will be from 0 to 2 pi cos phi ax cap plus sin phi ey cap plus this integration is broken in 0 to 2 pi 0 to 2 pi az cap simply. Okay, and all of at the end obviously d phi is there. You cannot forget a d phi. Okay, d phi d phi d phi. So here one thing I notice that ax cap, right? Ax cap is actually not a function of phi. Ax cap is not a function of phi. It is like there is no angle change, right? Where did that diagram go? Is this depending on the phi? No, right? Ax cap is in this one direction only, it doesn't depend on the phi. Okay, so ax cap is independent of phi, so I can take this ax cap outside. And what is the integration from 0 to 2 pi of cos phi? 0. So this will be 0. Okay, and what is the integration? Like ay cap is also independent of phi, so this can also come out. What is the integration from 0 to 2 pi of sin phi? 0 plus 2 pi into az cap. So this integration answer will be 2 pi az cap. So this is a very good question. Okay, this question you should try to solve all these types of question, right? Okay, so there is another question that I have. I'll just delete this slide. So mainly I'm just solving questions to clear all the concepts, whatever doubt you have. Okay, so we have to determine the component of the vector m minus z ay plus y az at the point this, that is directed towards the point this. Okay, so how do I determine that? So I have to determine the component of vector at the point this. So this point is there at this point, that is directed towards q. So how do I determine that what is directed towards q? So I have to find out the direction of q. So direction of q will be simply OQ vector divided by magnitude of OQ vector. Okay, this will give me the unit vector on the direction of OQ. So on the direction I have to find out this, right? I have to simply find out this. So this will be okay, this first of all, this is given in the what do you say, this is given in the cylindrical coordinate system, because this I should have mentioned cylindrical, because this is not angular, this is simply a number. So I can simply convert this into spherical, right? I can simply convert this into spherical. So how do I convert this into spherical? So this OQ vector, like Q vector, I can write this like this as well. This will be rho cos phi. So root 3 into cos 60. Root 3 into cos 60 will be, cos 60 is root 3 by 2, not root 3 by 2, sorry, 1 by 2. So this will be root 3 by 2 x cap, and this will be minus, this will be root 3 into 3 by 2, so this will be 3 by 4 actually, ay cap, plus z is z itself, az cap. Okay, okay, this is what I get. Now if I simply want to write the OQ direction, if I simply want to write the OQ direction, what will be the OQ direction? So OQ direction will be this, right? If I, yeah, OQ direction, okay, so what will be the unit vector? Unit vector will be, so this is actually my OQ vector. Unit vector will be OQ vector divided by the magnitude of OQ vector. Okay, so now what will be next? Now basically what do we do? We have to do this, right? We have to do this. What is it? Basically I have a vector like this, we have taught in basics class 10. Let's say M vector, and I have been given another vector OQ, and I have to find the component that is present on this OQ vector, right? What will be it? If the angle between these two vectors are theta, then the component will be simply M cos theta, right? And what is M cos theta? It is simply this. Let's name a new vector, that is OP vector, that will be basically M cos theta, that is magnitude of M cos theta. Or if I want to directly write it in vector format, magnitude of M cos theta in the direction of AOQ. Okay, so what is this? This is magnitude of M cos theta, and this actually is OQ vector divided by the magnitude of OQ. This, right? What is this actually? This actually is simply, if I do the dot product, right? If I do M dot am I correct? Yeah, if I do M dot AOQ, okay, I will get my answer. Okay, I will get the unit vector. Okay, or I will get the component that is present on the OQ. Okay, that is my OP vector. That is it, because the magnitude of this is what, 1, right? So this is the homework for you to compute. I will just not compute because that will take us time. What is M vector? What is M vector? M vector is this, right? And I have to put the points as well. So x is 0, doesn't matter. Z is 3ay minus 3ay and minus 2az. Minus 3ay and y minus 2az. Okay, dot AOQ. What is AOQ? This divided by the magnitude. I know I'm not taking care of the magnitude for now, so I'll just take care of this component. Magnitude we can divide later on, right? Divide by the magnitude, which I'm not taking care right now. That's just a calculation that I hope you can do. Okay, so what will be this? This will be minus minus become plus, so 9 by 4, and this becomes minus 2. Wow, divide by basically the magnitude of OQ. Okay, whatever the magnitude of OQ is, that will be my answer of this. I need the magnitude of this, right? I don't need the vector directly. I just need the magnitude of this, right? So magnitude of OP, because they just want us to find the component. So this will be, what will be the magnitude of this? This is right. If I just multiply 4 and divide by square root of 3.755 into 1 divided by 8, this will be 0.9095. okay, this will be the answer. Pretty straightforward. This is like class 11 level question, not that difficult. Okay, these basic questions can also come sometimes like in spherical vector format. Okay, this will be helpful in the main main topics, right? So now we'll learn about gradient, divergence and curl of different coordinate systems. So like pretty simple. This is, how do you remember this? This you have to remember, very important. This you can put in short notes. Okay, this you have to put in short notes. That conversion part, right? That matrix format, that also you have to put in short notes. And how to remember that also you have to write in short notes in your own language. So few things you have to remember. Unfortunately, few things you have to remember. First is, you already know what is gradient, what is divergence and what is curl. Okay, in Cartesian we already know all this. But in cylindrical and spherical, things become changed. Things become a bit different. U, V and W are the variables of that particular coordinate system. In case of Cartesian, it is X, Y, Z. In case of cylindrical, it is rho, phi and Z. In case of spherical, it is R, theta, phi. Okay, good. This portion is good. Now what is H1, H2 and H3? This you have to remember. Okay. In case of X, Y and Z, it is simply 1. In case of cylindrical, things will change. How do you remember this row? That I will explain. In case of cylindrical, this will be 1, this will be rho and this will be 1. Okay, why is this 1? Simple direct conversion. Z equals to Z. Okay, why is this row? Why this row is 1? I will explain. Why is this row? I will explain. Then in case of spherical, this will be again 1 only. H1 will be 1. This will be R and this will be R sine theta. Because Z is equals to what? Z is equals to what? Z equals to R sine theta. That's why. And you might ask, sir, rho equals to R cos theta. But here we don't have any rho. So that's why R cos theta doesn't come. How does this R comes? I will explain. Okay. R sine theta, how did it came? Simple. Z equals to R sine theta. Like that. Okay. This is R, this is 1. This you have to remember. And how to remember, I will explain now. Okay. Your gradient expression will be, everything will be same. Okay. Like a Cartesian, but A 1 by H1, 1 by H2 and 1 by H3 will come at the coefficient of all these particular expressions. Okay, this expression I hope you recall already. This was simply Cartesian expression of gradient. Just in front of this, okay, I will have 1 by H1, 1 by H2, 1 by H3. Okay, in the inverse format. This I hope you understand, right? Partially differentiating of the function with respect to the first variable, partially differentiating of the function with respect to the second variable, partially differentiating of the function with respect to the third variable. Okay, this format you have to remember. This you have to put in short notes. Point 1. What about the divergence? Okay, what about the divergence? So divergence is basically this. This looks a bit scary, but don't get scared. Okay, trust me, don't get scared. If I have a vector like this in U component, V component and W component, U, V, W can be X, Y, Z, can be rho, phi, Z, can be R, theta, phi. Got it? These are the coefficients of those components. Divergence of that particular vector will be, first of all, whatever I do, I will divide by 1 by H1, H2, H3. This will be the coefficient. Okay, H1, H2, H3 are here. Next, I will partially differentiate with respect to this component, but H2, H3 will be multiplied. In case of Cartesian, this is 1, 1, so it doesn't affect. But in case of cylindrical, what you have to do, you have to hide the H1. You have to hide the first column, just multiply the second and third column, right? Row and 1. Okay, here this H2, H3 are row and 1, and AU will be here. Then again here, this is del by del V. Del by del V is simply H1 times H3 into AV. Okay, H1 and H3. What is H1? H1 is simply 1 and H3 is simply 1. Again, I will hide the second row. When I am computing the divergence for the second component, I will hide the second row. When I am computing the divergence for the third component, I will hide the third row. Anyhow, how you want to remember, you can remember this. Okay, this is up to you. And for curl as well, again this coefficient will come, 1 by H1, H2, H3 will come, but the format will be different. Here, right, in the top, it will not be simple AX, AY, AZ. Here, this will be with its own component, that is H1. Here I will write the H1, here I will write the H2, here I will write the H3. This is for rho phi z, this is for r theta phi. Okay, anyway, anyhow you want. This will be same, this will be same. Okay, this again I will copy paste. Okay, this will be multiplied by H1 times AU. Okay, the first component, H2 times the second component. Okay, this is not R, sorry, this should be AV. And this will be with the third component, right? H3 with AW. Okay, that's it. That's pretty much it. So this format, unfortunately, you have to remember. Now, how does this row come actually? This row, right? How does this H2 row comes? You can remember it in as the concept of differential length. So this, right? I cannot simply write phi over here. Why I cannot simply write phi? Because this is, what is its unit length? This is radians. I have to make it length. How do I make it length? By this, multiplying rho d phi. So this becomes a differential length or arc length, right? Arc length. So I have to make the units same. Here this is dz, so this doesn't change. So that's why h1 is only 1. I hope you understand why this row comes. Here this is dr, this is again length, that's fine. This should not change. Here this is r d theta, again this is again the arc length, right? R d theta is the arc length. This should be phi, this should be theta. Again the arc length. This is r sin theta d phi. Again in the phi, right? It is in the xy plane. So in the xy plane I have rho actually. Rho, this was the rho, right? This was rho d phi. If you remember, this was the rho d phi. I just converted rho into r sin theta. I just converted rho into r sin theta. That's it. Converted rho into r sin theta. So this again is arc length. I have to convert this into length. So that's why h3 comes out to be like this. Okay, that's why h3 comes out to be like this. Now I hope you remember, understand that why is the h3 rho r sin phi, r sin theta. Okay, again this is arc length. I have to convert the units, right? I have to make the units proper. Okay, now you just follow the same thing, divergence. Okay, for cylindrical, divergence for spherical, you will get this formats which I taught you in the 2 slides before. Again the this curl, right? This curl, not even this curl. Also again, if you just replace the h1, h2, h3 with their respective values, you will get back this format, right, in cylindrical and spherical. So now mainly we will do few questions and we will end our lecture. So this is the first question. So what I will recommend you just pause the video and try to solve all these questions. This is the first question, this is the second question, this is the third question, this is the fourth question, and anything else. This is the fifth question, sixth question, and that's it. I think, yeah, that's basically it. So 6 questions we'll solve and then we'll wrap up our lecture. So I hope you have paused the video and try to solve. So for this first question is pretty simple. This came in GATE 2015 from the electrical branch. So even though you don't know everything, you don't know about, although you know everything, right? You have already, okay, Gauss theorem you don't know, except that you know everything else, right? In mathematics you have already learned this. So we have to match the following basically. Stokes theorem is actually what? It relates the closed line integration with the surface integration, open surface integration. So here this is there, right? Closed line integration with the surface integration. So P should be equals to 4. P should be equals to 4. So this I know for sure. P is equals to 4. What about Gauss's theorem? Gauss theorem is what? Gauss theorem actually relates the charge enclosed within a electric field, okay, within a particular closed surface. Okay, so if you don't know, don't worry, we will study this. So Gauss theorem relates with this. This is the Q, right? Q equals to D dot ds. It relates with the closed surface integration. So Gauss theorem relates with the closed surface integration. So Q will be simply 1. What about divergence theorem? Divergence theorem basically relates the volume integration with the closed surface integration, right? So closed surface integration with the volume integration. So this will be the divergence theorem. So R will be simply 3. What about S? Cauchy's integral theorem. Cauchy's integral theorem says if any pole is lying inside that particular region, analytic function, that integration of that particular thing will be if it is lying outside it, line integration of that particular thing will be 0. That is what Cauchy's integral theorem says. We have learned this in the complex variable portion. So S will be simply 2, although only one option is remaining, so obviously that will be that. But which is matching? 4 1 3 2. 4 1 3 2. So option B will be correct. Option B will be correct. Simple, right? Now few things you have to compute the divergence of the following vectors. Can you compute the divergence? So first one I will compute. I will give you homework as a second. Okay, other two. So how do we compute the divergence? Remember with me. Just write down the expression. How do you compute the divergence? Divergence of any function f is equals to, if you remember it, always 1 by h1, h2, h3 will be present. Divergence and curl 1 by h1, h2, h3 will be present. For gradient, things are bit different. Okay. So this 1 by h1, h2, h3 is there, and then what I do differentiation of the first component. So this is in R, right? So R, this is in spherical coordinate system. So this will be del R h2 into h3. H2 is what? H1 I will ignore. H2 into H3. H2 is, if you remember, it is R d theta, right? So it will be R, and H3 is what? R sin theta. So it will be R sin theta. And obviously I have the component of the R cap, that is 1. Coefficient is 1, so this will be simply 1. And other components are 0, so other components will be simply 0, right? Other components will be simply 0 differentiation, because other components are 0. If I multiply by 0, it will simply become 0. Okay. So what will this become? So h1, h2, h3 is what? This is simply r square sin theta, 1 by r square sin theta. So if I differentiate this with respect to r partially, so this will be 2r into sin theta. Okay, so this will be 2 by r. Okay, so your answer will be 2 by r. Similarly, can you solve the other two? Okay, that is the homework for you. Now let's come back to next question. So next question is this: the figures show diagrammatic representation of vector fields x, y, z. Which one of the following is true? Okay, so I hope you have understood the significance of divergence, curl, and gradient from Himanshu. Okay, and I've taught this in my own vector calculus lectures as well. Okay, the significance. So here, right, divergence means how much flux is going in or going out. Okay, so if I observe, this is the x vector, and here divergence means like this is net, like here, right? Electric field is, all the electric field is going out from the surface, so net flux is not 0 through the surface for this. So divergence for this, right, will not be 0. I cannot comment about the rotational nature. Okay, so I cannot comment about that. What I can comment is del cross x will be 0, because here there is no rotation, right? So this much I can comment, that del cross x will be 0, because this doesn't have any rotational nature. Like I can see, observe, this has some rotational nature, right? So I can definitely say that del cross y will not be equal to 0, and this also has some rotational effect, right? So del cross z will also not be equals to 0. Okay, but I can definitely say that this is non-solenoidal. Why? Because some field is getting out through the surface, so I'm able to enclose all the fields through a surface. This is not 0, so del dot x will also not be equal to 0. So according to this, del dot x should not be equal to 0, del cross y should not be equal to 0, del cross z should not be equal to 0. So option A is correct. Why del dot x is equal to 0 is incorrect? Because this is not terminating, right? This is not totally like, this is not following a loop. Okay, not following a loop. So this will be 0. Del dot y will be 0. Del dot z I cannot comment. Del dot y will be 0, because this is forming a loop simply. Okay, this is not forming a loop. This is acting like a source. Okay, source free. Source, this is acting like a source, so this is giving some fields. So this divergence will not be 0. Okay, I hope you know the significance of divergence and curl. Okay, now this, for the vectors shown below, which of the following vectors can be expressed as gradient of a scalar? As a gradient of a scalar. If you remember, what is gradient of a scalar? What is gradient of a scalar? Gradient of a scalar. Which of the vectors can be represented as a gradient of a scalar? Vector is equals to, I have to represent these vectors as a gradient of a scalar. Let's say I have a scalar function this, and if I take the gradient, and that will give me vector. Which of the vectors can be represented as a gradient of a scalar? So Basically, if I take the gradient of any function, can I ever get back to this vector? Okay, can I get this vector if I take the gradient? So how do I go about this? How do I identify? Because I don't even know the starting point. So the starting point should be this, because I have taught this in my vector calculus chapter, the properties of del operator. One operator is there, this, that if I take the curl of a gradient of a scalar function, this should always give me a null vector. This should always give me a null vector. If it doesn't give me a null vector, then that means I will never be like that. That will never be a gradient of a function, scalar function. Okay, if I don't get a null vector. So in our case, this is the v, right? This is the v, because this is what they are asking. So the which can be expressed as a gradient of a scalar function. So if I just take the curl of this curl of gradient of a scalar function, okay, that should give me null. So if I take the curl of all this, that should give me null. Now if I am not getting a null function, that means they cannot be expressed as gradient of a scalar function. They cannot be expressed as gradient of a scalar function. So I will do exactly that only. So first I will take the gradient. So I will write here curl of gradient of scalar function should always give me null vector. So in other words, basically if I do the del cross v, I should always get null vector if the v is a gradient of a scalar function. Okay, so I'll verify each of them. So for option A, this is simple. This is in the Cartesian coordinate, so finding the curl of this is actually simple. So del cross v1 will be simply ax cap, ay cap, az cap, del x, del y, del z. And this will be simply, what is the x component? X component is yz, y component is xz, this is xy. This will be, I think this will be equals to 0. So this, right, this is simply, okay, this is simply z, this is also z. So this is again 0, this is okay, not do this, this is x, fine, this is y, this is y, fine, and this is z, this is z. So this comes out to be 0. So this first option is correct. So this can be a gradient of a scalar function. Let's check the option B. The option B is interesting. Why is it interesting? I will just explain. Here it is in some other coordinates. Right, what coordinate it is in? It is again in xyz only. Okay, this is in xyz only. So this again becomes simpler only. Sorry for that. This becomes simple only. X, y, and z. This again becomes 0. Right? This again becomes 0 because partially differentiating this is 0. This is 0. This is 0. Everything is 0. So this again becomes 0. So what about the C function? C becomes interesting. Why does C become interesting? Because right now this is in some other coordinates. What coordinate it is in? So here if you observe, this is in the cylindrical coordinate, right? Rho and phi. This is in the cylindrical coordinate. So I have only a phi component actually. I have only phi component. So if I have phi component, what it is? So here I can say this is 1 by h1, h2, h3. In cylindrical I have only h2 is rho, right? So this will be rho. Here in front of phi I will have a rho. Okay, all of the other will be same. E rho, AZ, A5, AZ. Okay, so A row, what is D phi? This is 0, this is minus root 2 e raised to power minus row divided by row, and obviously I have to multiply by row as well, right? To multiply by row as well, if you remember, this was getting multiplied by row as well. And this is again 0, right? Although the components are 0. So this is a purely function of row itself. So if I just come on to compute, this is 0, this is with respect to z, this is 0 again. If I come on to compute this is 0, this is 0, fine. If I want to compute this, okay, this is not 0, this is not 0, right? So this is actually what this will be, differentiation with respect to row. So this will be minus root 2 e raised to power minus row, fine, and Ez, right? Ez cap. Okay, so this is not equals to null vector, so I cannot express this in terms of what? In terms of my as a gradient of a scalar. So C is not expressible in terms of gradient of a scalar. Okay, it is not expressible, right? So let's now move on to the next like example, this, right? D, this is in the spherical coordinate system now. This is V3, right? So this will be simply r square sine theta, because I have one is r, h2 is r, and h3 is r sine theta. So this will be r square sine theta. So this will change actually. This will be a5 will be this will be r and theta r. This will be ar. This will be r sine theta. This will be dd phi, this will be theta, this will be ddr. Okay, and this will be what? So here, right, one thing we have to understand is that this will be h1 into whatever component is present in the AR cap. So h1 is 1 only, so this will be simply sine phi by r square, and this will be h2 into whatever component is present in the theta direction. So h2 is r only, so this will be cos phi divided by r, and this component is 0 itself, right? So what is this actually? This is V4. So don't worry, this type of difficult question won't come, but something similar to this can come, right? Something shorter version, easier version of this. So I'm teaching you the most difficult version. Okay, so let's compute the curl of this. So this will be 1 by r square sine phi, and here, right, we have ER cap. So ER cap, this is 0, this is actually minus of sine phi divided by r ER cap, and this, right, this will be 0, and this will be again plus of cos phi by r square into r. A theta is there, so r will get cancelled and only e theta will be present. Okay, and this portion, right, this will be minus 1 by r square, and theta is 0, so this will be, okay, actually this is also non-zero, so we cannot express this, right? Minus 1 by not 1 actually, I'm doing this, right? So this is cos phi plus okay, already there is a minus sign. Previously there is a minus sign, I forgot there is a minus sign here actually. Okay, that doesn't matter here. Fine. Here is a minus sign, right? So this will be actually minus cos phi by r square, and this differentiation is simply 0, and I have r sine theta a phi. Okay, so yeah, this cancels out, and this actually is not equals to null vector. So obviously this we can also not express. So only a and b, not this page. Not this page actually, sorry. Only a and b can be expressed, right? Can be expressed as a curl of as gradient of a scalar. Gradient of a scalar. Okay, so this is the solution. This was a good question. Okay, this one I will give you homework. This is pretty simple. Just what you have to do is you have to compute the line integration of this v vector, okay, along the closed curve. You can break this down into 3 components and then solve for it. Okay, so how do you go about this? Simply what you will do, you will break this down into 3 segments. Okay, 3 segments. First from here to here, then from here to here, then from here to here. Okay, so what things are changing from here to here, that you have to observe. Like there is another segment. So what solution I will give you is this, right? What you can do, you can break it down into 4 segments actually, not 3. Not this. Okay, this will not change. It's fine. Break it down here. Okay, so this is like a circle, section of a circle with 0 radius, almost 0 radius, right? So here your phi, like in this, like let me change this into 4 curves. Let's name this as C1, let's name this as C2, let's name this as C3, and let's name this as C4. So in C1 what is happening? C1 actually I'm going from, my r is varying, right? R is going from 0 to okay, this is in the cylindrical coordinate. R is varying from 0 to some value. So okay, I haven't like written the values here. I just write the values and come back. Yeah, I have written the value. So radius is 1. So here, right, my r is changing from 0 to 1. But in C1 actually only r is varying. My phi is constant. Phi and theta are constant. Okay, here my r is constant, right? This radius is 1. Okay, r is constant, r and phi are constant, but my theta is varying from what? Theta is varying from 0 to, not 0, sorry, pi by 2 to 90. I just need to find the length, so I will not take care of the direction. So pi by 2 to 0, and here my r is varying from 0 to 1, and in this curve, right, in this curve my r is again varying from 0 to 1. Okay, although this is in the opposite direction, but variation of r is there, and my phi and theta are again constant. Okay, phi and theta are constant. R is variable going from 1 to 0, and in the next case, right, last case, r is 0. Okay, r is 0. R and phi are again constant, but my theta, right, is going from 0 to pi by 2. That's how I totally complete a whole curve. Okay, so this r is here 0. So just the homework for you is just to compute this. Okay, that's the homework. Let's go to this question. So this question is, we have electric field. Okay, we have to compute the volume integral, right? Volume integral of this del dot E, where V is the volume enclosed by unit cube. Okay, from Z1. These type of question always come. This is very simple. How do you solve? just find the divergence. This they have given in Cartesian coordinate. So pretty simple. This becomes 4x 4x plus 5 plus 3 dx dy dz. Like dv can be expressed as dx dy dz, and x is varying from 0 to 1, y is varying from 0 to 1, z is varying from 0 to 1. So this becomes simple. This is like 8 times the volume of a cube. So this becomes 8 units plus unit cube plus, what is this? This is 4x dx, right? So it will be x square by 2. So this will become 2x square. 2x square going from 0 to 1. So this will be 2 times 1. Okay. So this will become 10. So like I have just done a bit fast. So I'll do it a bit slow. So this, right, this will become 2x square plus integration of dv of a cube, right? 0 to 1, 0 to 1, 0 to 1, and 8 is obviously there. 8 is a constant. This is 0 to 1, and dx I have already integrated. So this, here, right, only dy and dz are there, and x value is already given. X is going from 0 to 1. So this actually, so this value will be 2. Okay. So 2 plus 8 will be simply 10. 10 unit cube. So option B, C will be answer. Okay, C will be the correct answer. So this was pretty simple. So yeah, this was basically these were few questions that I wanted to solve in this extra lecture. So those questions I will solve in the homework, okay, and those you will try to solve by yourself, because few questions I will not solve in front of you. Few questions you have to solve by yourself, then only you will utilize your brain, because I know you will just watch the notes and that's it, and that's not a way to learn. You have to write down the things by your own. Okay, then only you will be able to understand all this. So with this we have completed our basics of vector algebra. From the next lectures onwards, we'll start with electrostatics. Thank you for watching, and I will see you in the next lecture.